Hi, this is Miss Smith here, bringing you a video for enrichology tutoring. This one is over complex numbers and how we utilize them, graph them, and such. So I'm starting off here with the complex plane. So we talked about how you cannot find the square root of a negative number, but if you created an imaginary number or I and created a whole plane that exists with it, now we can graphically depict these numbers. So I have a couple that I'm going to plot over here on my imaginary plane. I have the typically y-axis is going to be the imaginary. The x is our real. And these are numbers, of course, like 1, 2, 3, 4, 5, and such. And same thing over here. There's -1, -2, -3, -4, all reals. And then this will be like 1i, 2i, 3i, and such. And this is -1i, -2i, -3i, and such. So the first one I have, a is 3 minus 4i. So my real number right here is 3, and my imaginary number is 4i, so -4i. So I'm going to go down here, and I have my point. I'll label it 3, -4i. Done. Now I'm going to do another point. Let's see, -2 plus 3i. Go ahead and think to yourself for a moment, where should that be? And I'm going to go ahead and graph it. So I have -2 and 3i. So that should be right here. -2 and 3i plus 3i. All right, let's plot another one. So we're going to plot C, 5i. You can pause the video right here and take a moment to think about where you think 5i is going to be. And now plotting 5i. 5i will be approximately right here. Oh, nope. Hold up. Wait a minute. That's -5i. So 5i should be right here because it's positive 5i. All right. And then the last one, 2. Where should I plot 2? Right here. So when we're using the complex numbers, there is also something called the complex plane, and it does not need to be intimidating. The x-axis is still reals like we usually do, but the y-axis is now turned into our imaginary axis and when we plot them. Now in the last video, I didn't show a lot of addition and subtraction of complex numbers, but here I'm gonna go ahead and do that. So if I have this binomial plus this binomial, and it's since it's positive right here, I can effectively distribute this positive to both of the terms inside of this one and get rid of my parentheses thereby. So I am left with 8 minus I plus 5 plus 4i, which gives me 13 plus 3i when I combine like terms. And I'm going to do the same thing here. I have a negative sign outside of this binomial. I can distribute that negative sign, which is effectively multiplying everything in there times a -1. And so I'm left with a -3 and a positive 6i. And I'm going to go ahead and take this out of my parentheses and combine like terms. And now I'm left with 2. Oh, I cancels out. 6i, positive 6i, -6i. And I'm just left with 4, real number of 4. All right. Now, application of complex numbers. So this is a circuit. We have a resistor, a capacitor, and we have a inductor over here. So they each impede the flow of electricity through the circuit. However, they have different impedance. This one, being a resistor, is 6 ohms. It's a real one, 6, and we just write 6 ohms. Now, my capacitor here, this one is my inductor. This one here is going to have impedance of a 4i, or 4i ohms. And my capacitor right here, it has impedance also of an I. It's 5i, but it's negative. It's because of a difference in how these two things or these two components impede electricity. So to note that distance or difference, I'm going to put this as -5i ohms. Now the total resistance, or not resistance, impedance of the system, if I add these together for 6 plus 4i minus 5i. End up with 6 minus 1i. And that is the total impedance, or 6 minus 1i ohms. That's the total impedance of my system. All right, so there we go. We have the graphing of a complex number, or how do we graph complex numbers? How do we add or subtract complex numbers? And then finally, a practical application of complex numbers and how we use them. All right, see you in the next video.